Today we are doing Module 4, Lesson 23, and you can see that your learning goal is the same as yesterday. Just like yesterday, we are comparing the size of the product to the size of the factors. Okay, so today we're just adding on to yesterday's lesson. But first, let's get started with the problem of the day. Before we go on with today's lesson, let's first talk about how we can write fractions as decimals. If I have 1/50th over here, and I want to write an equivalent fraction, how do I go from how did I change the denominator from 50 to 100? What did I have to do? Multiply by 2, which means in the numerator, I also need to do what? So do you agree that 2 100ths is the same as 1/50th? Now, how do I write 2 100ths as a decimal? It's 2 hundredths. So I need a 2 in the hundredths place. So 1/50th is equal to 2 hundredths. Do you agree? Yeah. Take a moment to write that down. These examples show us that to write fractions as decimals, we need to first write an equivalent fraction where the denominator is a multiple of what number? Sorry, not a multiple. It should say a power. So change it. A power of, well, what was our denominator here? Yeah, we changed it from the original denominator of 20 to a denominator of 100. Over here, our original denominator was 50, but we changed it to what? 100. Over here, our original denominator was 4, but we changed it to, So it seems like to write fractions as decimals, we always need to change that fraction so that we will have an equivalent fraction where the denominator is a power of 10. Because if we think about the place values, tenths, hundredths, thousandths, those are all powers of 10. Okay, as you remember from yesterday, scaling factors are the ones that are changing the size of the other factors. So you can see in all three examples, we're starting with 2 meters, but we're going to change the size. So the first scaling factor is 97 100ths. The second scaling factor is 101 100ths. And the third scaling factor is 100 over 100. Okay, what can we tell right away about 100 over 100? That's equal to 1. So is this going to stay, is this last example going to be longer than 2 meters, shorter than 2 meters, or equal to 2 meters? Equal, right? Because 2 meters times 1 is going to be equal. Which one's going to be shorter than 2 meters? The one where we multiply it by 97 over 100, because 97 over 100 is less than what? 1. And then this one, 2 meters times 101 over 100 will be greater than 1. It's going to be greater than 1? It's going to be longer than 2 meters because the scaling factor is greater than 1. Isn't this reviewing what we did yesterday? Good. So on this slide, the scaling factor is 0.97, 1.01, and 1. Except, so Akshay says, hey, this is exactly the same as what we just wrote down. Do you guys agree? Except this time, the scaling factors are in decimal form instead of fraction form. Before, it said 97 over 100. Over here, it said 101 over 100. And over here, it said 100 over 100. Those all actually have the same value as the decimals, as we know, huh? So which one is going to be longer than 2 meters? The first one, the second one, or the third one? Yeah, this one will be longer than 2 meters because the scaling factor, 100 over 101 over 100, or 1.01, is larger than 1. Okay? Of course, this one will also still be shorter. We're just going to use decimals. Okay? So let's take a look at, go ahead and write this inequality. Remember, an inequality is a number sentence where instead of an equal sign, we have a greater than, less than, equal to or less, greater than or less than sign. Now, remember, here is your greater than or less than sign. The alligator's mouth always points to the bigger side. So which side is bigger? The left side or the right side? Okay, so we want this side to be bigger. That means I need to multiply 19.4 by something that is greater than 1, so that this side of the equation will be bigger. Okay? Write down a scaling factor in decimal form that would make this inequality true. An example might be 1.15. Is that scaling factor larger than 1? Yeah. So will it make 19.4 times 1.15 be larger than 19.4? Very good. Now looking at this second inequality, this time the alligator's mouth is pointing to the what side? Right side. One thing I like to do is I like to circle the side that should be bigger. Do you see how right now on the left side and the right side I have 19.4? That means I need to make this left side smaller, don't I? I need to scale this down so that this side of the inequality is less than this side. So what kind of scaling factor will I need? Something that is less than 1. What might be a number that works? Anything. 0.8. Is that less than 1? Very good. How could I write this 0.8 in fraction form? I could write it as a decimal or I could write it as a fraction. Can you read me 0.8 in word form? 8 tenths. So I could write it like 8 tenths. Do you see how word form is very closely related to fraction form, which is also basically the same as unit form? Right? Unit form, I would write 8 tenths. All of them are exactly the same thing. Okay? Here we have 19.4 times 0.96, and then also 19.4 times 0.02. Which ones are the scaling factors? Go ahead and circle them. Do you agree that 0.96 is a scaling factor and 0.02 is a scaling factor? Yes. Which one will have a smaller product, and how do you know? Go ahead and talk to your partners. The second expression, 19.4 times 0.02, will be a lot smaller because its scaling factor is a lot smaller than the other one, right? 0.96, the scaling factor is pretty close to 1. So the first expression, we can expect the answer to be pretty close to 19.4, just a little bit less, don't you think? Just slightly less. 0.02, is that a lot less than 1? In fact, it's really close to 0, right? How many hundredths is this? 200. How many hundredths is this? 96. Isn't there a difference between 2 and 96, right? So this is going to be a lot smaller than 19.4. Why is this skill useful to know? It helps you know if your final answer is reasonable. Thank you. We can see that if our scaling factor is pretty close to 1, it's only going to be slightly less than or slightly more than. The farther away it is from 1, the greater the change will be. Okay?